Okay, now when you start glowing up here, you're logged in, and you should see a little message that said you got a file. So Carol's good. She can unplug and move on out. The other Carol's in and done. Over here, the little message says that 2 people got it. And so you got a thing called ball bounce data. Okay, Vicky's in and done. Once you get it, it's pretty quick. Boom, boom. And once you've logged in, you don't have to log in again until I stop the class. So next time you plug in, you get it right away. You will have to have a password, and it will have to be at least 3 characters. I got 7 of 8 folks got it. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So 1 person did not get it. Okay. And if I click on this, I think I got it outlined. I can see that Lois is not with us. Okay. So I can click on the particular thing I sent, and everybody green got it, and the red folk didn't get it. So we need to fix Lois. Okay. All right, so you have a document that you've been working on. And in some cases, it's an untitled document. And so if I hit escape and go back into the current document, number 4, then this is a thing called unsaved with an asterisk. Now, if it says something different, it's because you opened a file and you started writing in it. And it's okay with me if you obliterate it, but you might get this set. No, this set goes back to Banner Drive, so you could screw it up, and they have people in the basement that fix things. So if you were on the computer and you wanted to save something, what would you do? Save as opposed to save. Okay, and the reason that he's doing save as is that he wants to give it a name. But you can do save the very first time, and it's the very first time it's treated as a save as. So I'll show you both ways. Control S is save. Now, it's the very first time you do it, it's really a save as. And so you can see I have 2 folders. You probably have more. If you remember, somebody mentioned the examples folder. But you have a folder called DISD, except it's DSID. And that's supposed to be Dallas School Independent District. Okay? And so what happened is that when you logged in, it sent that file to that folder. And so, but here it's saying, like, what do you want to call it, the thing that you were working on? And then where do you want to save it? So this is a little more time consuming than I want to spend with, but I will tell you that it's kind of an essential part of living your life with technology. What was it called? Where was it saved? Get something from the internet, download it, where to go, what was it called? And then the third part is like, what application do I use to do that? So I will just save it right here. And now it's called document 1, has no asterisk and whatever. Now, if I make a change in it, then I get the asterisk back. But since I've already saved it, Control S, the only thing it will do is just update it, because it's still called document 1. So after the very first time, it's not a save as. But if you press doc, there is a file option to save as. And so now you get that save as the second time. Okay. So what I'm telling you is that if you go to House, where do you think your documents are? In my documents, number 2. And then I don't see it here because I didn't load it into this calculator. I loaded it into my calculator. So I will do this. I will go into my documents, wherever it is. And then in this folder called TI Nspire that I created when I installed it. Do you see this document 1 that I just saved? Mm-hmm. And so I want to make a folder called DSID because I want to be like you. And then I want to go get that file, which is right here. And incidentally, I wouldn't do this in front of kids. I would have done it before, but maybe doing it in front of you is probably not too bad. And then I'll paste it here, and if I go now back to my virtual calculator, I can see that I have a DISD folder. So for you to have your calculator look like theirs, you could create under My Documents, under TI Nspire, a folder by the name of the class that you created, first period, second period, third period, and put stuff in there. Okay. So I would go here, and how do I open this up? It's like a folder. I could double click, and one click opens it up, and then if there are several things there, the double click would have opened up the first one in the list. Turns out that this is the first one in the list. Now here's the challenge that I talked to you about earlier, and again just a few minutes ago, is that if you're trying to open one, do you want to save the thing that was there before? And I'll say no, because they're a chump, because they turned over the computer to me without saving it. Okay, so I have some data for ball bounce. And so if you look at the next page, you can see a spreadsheet of data for a bouncing ball. So one of the things that you could do is you could take data from the internet and from an Excel file, from an experiment, and dump it in a spreadsheet. Now just looking at this number, can you tell me anything about any patterns you see? Okay, given time, I'll go ahead and answer my own question. There's two variables. Turns out that somebody named them time and height. Not sure what the numbers stand for, but I'm thinking since it's a ball bounce, it might be the time and how high the ball was above the ground. So for example, at 0 time, where was the ball? It was at 0 in terms of my frame reference. For example, if the ball was on the floor, is it at 0 height? No, because we're on the second floor, right? But from my frame of reference, it is. Okay, so that's frame of reference for physics, and we need to know that. Like everything is relative to some origin that the math people teach about all the time. They got their origin and their Dulciani. Okay, so then the time seems to be changing by five hundredths. There's a street name for that? 500ths, and there's a street name for 500ths? You don't go up there and say, I need 500ths of a case of Diet Dr. Pepper, do you? It's a nickel, okay? A 20th, very good. So it's a 20th of a second. So how many would I get in a second? 20. But if I said 500ths, how many would I get in a second? I don't think you could excrete that very fast. Okay? So what's the sense of calling that 1/20th? Well, you can tell the kid that in 1 second I get 20 data points. Now, I don't know if you know how to bounce a ball, but it's sort of like this, except it's much more effective. Okay? And so in that time period, how many 20ths of a second what was there? Did we have? Just, okay, was that like 20ths of a second? 1 Mississippi, 2 Mississippi, or do what you say, 1 Louisiana? 2 Louisiana? We say 1 Mississippi, 2. Okay. So anyway, so just looking down this list, which you can scroll down if you want to, I can see that after 1/20th of a second, the object was at 85 centimeters. Maybe 85 miles, 85 angstroms, 85. I don't even know that these are seconds, right? Now, a couple of things. Would this be times or time? Would this be heights or height? Okay. Do you have protocol? Don't ever name a column a plural, right? Would this be seconds in height? If this was seconds, this would be what? Now, my kids have trouble understanding the difference between meters and height, between seconds and time. They think they're the same thing. Okay. All right, so whoever did this chose to call this time, but they didn't put units in it, so maybe it doesn't matter, maybe they don't know. But if you look at this, if these are meters, what do we got? Nanoangstroms? See the number? Told you those motion detectors are good. Okay. All right, so what will happen is that you get more digits here than you're worthy of, although if this was in light years, that might be appropriate. Don't you think? How far is that in light years? And they say, light years is time, Mr. Young. And I said, just because the internet says it's so. So anyway, so here's the data. So I can put data in this stuff. So for example, I could go over here and press equals and put in quotes. How do you get quotes? Can't see that keyboard. Control multiply. And then I could put in, notice that all went in quotes, and so it's treated as a literal expression as opposed to a number like the comment line on your, and so if I press enter, I could see that this line then represents the initial conditions. So I could do other comments there, I could put in other things, I could create my own list, or whatever. Okay. So the next thing we'd want to do is to look at a plot of this list, and so let's go ahead and go into a data and stat page. So introduce a data and stat page. And Carol, since you're our GT, would you come up and do it for us? So she's going to introduce a data and stat page.
I think you go to menu.
Okay.
And then you go to 3.
Nope, that's not it.
Ooh.
Escape. Maybe house, escape again. Okay. And she's choosing that one, which is a data and stat, she thinks. Nope, that's a list and spreadsheet. Control Z could undo it if she wanted to, but if not, then she's thinking that one. Go ahead and take the shot. What's the worst that can happen? Okay, this is a data and stat. Very good. Thank you very much. Okay, so she went to house and chose data and stat. Again, when you hover on the house, it tells you what they are, but you have to hover. You have to get your pointer there. Otherwise, you're just guessing symbology. And this is a much more revealing identifier than this, because there's nothing on this page particularly that tells me it's a data and stat. It just looks like a bunch of jibber jabber. Okay, so what we want to do is we want to tell it what we'd like to see, and since we named our list, we can put down at the bottom or over on the left different names for the columns. So would you like to see this as time versus distance or distance versus time? Or maybe I should ask it on a more basal level, what should go on the x-axis? Okay, so you can tab, and that'll put you down here, or you can move your cursor and click. Now, when I get down here, it has a couple of choices. So choose the choice that you chose to choose. And because of the pacing there, it doesn't really show that we did a 20th of a second. It just looks like they're lined up like they should be. Now tab over to the other axis, or move your cursor and click if you like. And then choose the height. Now, this first data point must have been bad, okay, because it actually started at 85 centimeters. And then if you'd looked at those other numbers, you would have seen that there's 2 bad numbers there, and then there's a good number, and if you went down, you would see that actually it was 86 for a while. So the good stuff actually doesn't happen until a little bit later, like right there. And if you point at one of these, it will get all excited. Okay. How long do you think this experiment lasted? Okay, 5 time units, which we probably think is seconds. And it just got less and less and less, which is what actually happened with the book. You just didn't see it. It got less a lot faster. And so I could look at, say, one bounce. Say the bounce that goes from here. I think I'm out of alignment a little bit. From this point to this point. Turns out that when you click on these, they stay clicked until you click on the white space. And so those are the 2 base points, the ones that are flashing, that are points of interest for my experiment. And so I might just want to look at that particular bounce. So any estimate about what that number is on the time?
Well, you can just go down there and it'll show you.
Okay, it'll show it to you. 0.85 seconds, and then this is 1.6 seconds. Okay, so I want to go back to this page, and I want to go down to 0.85 seconds, and I want to copy that bounce. Okay, so how do you copy? You have to highlight it first. Control-C will copy what's highlighted. And so how do I highlight stuff? Hold down the Shift key and then move with my arrows. Would you say 1.6? Or was it 1.65? Okay, so highlight from 0.85 down to 1.6, but also get the distances. Okay, so hold down your Shift. You could actually go by columns if you wanted to. 1.6? I think 1.6. I got excited, sorry. Okay. 0.85 is the first time, and then 1.6 was the last time. Our goal is to get you familiar with the Nspire well enough so that you can use the Nspires that you're going to get with the motion detector and this particular lab. So we're ready to move into this lab with one more step involved, and that is how to use the motion detector or the data collection. So I'm going to show you that, and I'm going to model what you'll need to do to show the kids on your computer as well. So just bring some real close closure to this. I guess I would step back to where I was when they told me to stop, is the teaks involved. And so you need to kick that up a notch. You got the list. So be thinking about what are we trying to do here with this lab. So in this case, though, this is separate. And so I've copied this and I pasted it into a new environment. Or actually, I think I copied it. I'll copy it again. Control-C. And then I'll go to House and I'll put in another spreadsheet and I'll Control-V and paste it. I need to name it something new. And so in the very, very top line of this is names for columns, and they're needed if you ever want to use that data outside of this page. So they're not always needed, but if you wanted to use this column of data somewhere else, and in a calculation or in data and stat or in a graph, you would have to have a name. The second line is the diamond line for you Excel folks. That's where you put your formula in. So if you wanted to do a formula like take all of these and take the first derivative and get the velocities, right? Then you could do that as an operation. The other thing is there are some limitations. I would probably call this time 1. And notice I use uppercase T. This is not case sensitive, so I'll lose my uppercase. It doesn't allow spaces, as we found out, and so the underscore is a typical way to put, but you could do ONE if you wanted to. And then I'll call this bounce 1. Okay, so, and you can expand these columns if you want to, but I'm not going to go into that right now. So remember how we saw a plot of the other stuff? So I'll insert with a Control I. A data and stat, and down here I'll put in time 1, and over here I'll put in bounce 1, and then that's that one pristine bounce. So from this, I could put in the name of a line that went through there. I could have the computer do it. I could guess and test it. And I won't do either now because we're running short of time. But that's what I had planned. So on the menu, there's an option to analyze. You could put in a movable line, but that's only for straight segments. And so that's only a straight line, so that's not going to work. I could plot a function, which means I could put in -1/2 gt squared plus v sub 0 t plus s sub 0. Or I could have the computer do a regression of a quadratic kind and name it. Okay, a little fast. That's okay. 1/2 gt, 1/2 g. Anybody do 1/2 g? AP people call it 5. Half of 9.81. Okay, not bad. Initial velocity 11 means that it left the floor at 11 meters per second. And this is a point of orientation that has to do with the fact that we started time at some place. Okay. So this is because it's not time 0. Okay, so I could then ask it to graph the antiderivative of that, or the derivative of that to get the velocity versus time. I could put it on there. I could come up with it myself or whatever. You know what it is, just offhand? I lost it because I pressed here, but if I can press here, I can get it back. So wouldn't it be the derivative is 2 times that times x to the first power plus this is a constant? So that would be 9.2, 9.3, and that's 11.46. So I could, on the menu, put in a analyze and plot a function which was what, negative 9.6 x plus 11.6 and I think I'm off a little bit, but maybe not. This should hit 0 at that peak, right? Because you hit a 0 velocity. You can change your window here to show that hits the 0. Okay. So anyway, so I can take some data, either type it in, get it from someplace, maybe from your motion detector, maybe from the internet, whatever. I can plot it and whatever.